angles to one another. There's another special type of angles in this diagram we've been talking about. What is that? Yes, ma'am. What are they called? Nope. Yes. Linear pair, right? So look, in the diagram we call them a linear pair. So for example, angle 1 and 2 is a linear pair. And then in the definition of linear pair, it says that those angles are supplementary. So you first have to state that they're a linear pair. Then you can say they're supplementary because of the definition of a linear pair. Then you can write an equation and say that their measurements sum up to be 180 degrees. Okay. So now what we're doing is we're going to relate these two intersections. So we're going to start comparing angles in two different intersections. So what I want you to do with these colored pencils is we're going to kind of break this diagram up into different sections. So we see that there's two lines that are generally going in the same direction. This space that's in between the two lines, I want you to take one of the colors and just lightly shade in between those two lines. Lines N and line N. So just lightly shade in, lightly color that region that is in between the two lines. We're going to refer to that area as being the interior of this diagram. This is the interior. So now, take that same color and write boldly interior. If you're coloring with yellow, then write with pencil. Like with your actual lead pencil. Number 2 pencil. But this space is in the, we're going to refer to as the interior. How many angles are in the interior of this diagram? What's up, Gavin? 4, right? Angles 3, 4, 5, and 6, those are in the interior. Okay, so those angles are referred to as interior angles in this case, in this situation. Now I want you to switch colors with your 3 friends. So everyone should have a different color. And in that different color, I want you to shade above line N and below line M. This region, or this area of this diagram is referred to as the exterior. So lightly shade it in, and then boldly write exterior. We're going to refer to that as the exterior. How many angles are in the exterior of this diagram?
4.
Also 4. So the way that I've numbered these, angles 1, 2, 7, and 8 are in the exterior of this diagram. Now I want you to trade one more time. So you should have a completely different color, whatever color you haven't used yet, of the 3. And I just want you to trace line T. Shade in line T. And then I want you to write transversal. So that is your transversal. Now, I'm kind of a nerd, so like one of my favorite TV shows is The Big Bang Theory, because like they legitimately have professors from MIT that write some of their scripts. So like the stuff that they're actually talking about, the equations that are on their boards, that is all legit, completely accurate, everything that they talk about. And I saw an interview with one of Jim Parsons. He plays the lead role, the lead character, Sheldon. He's the smartest out of them, but he's also the most socially awkward person that's ever existed. And so Leonard, his roommate, was trying to impress one of the female actors, and her name is Penny. So he's trying to learn how to play football and all the rules and whatnot. So they're hanging out in the apartment trying to figure out, and they got like a book like Football for Dummies. And little did they know, the most awkward unathletic person of their bunch, Sheldon, knew all about football because he was born and raised in Texas, and so his dad taught him football and made him watch football before he could do his calculus homework at night. So he knew all about it. Well, Leonard couldn't figure out the line of scrimmage. Didn't understand the importance of it, didn't understand how that related to the downs, where it was, did it move. He just completely didn't understand the line of scrimmage. So Sheldon actually defines the line of scrimmage using the word transverse, the transverse line. And so it is an imaginary transverse line that separates the offense and the defense. So that's an example of a transversal that we see in Texas, at least, all the stinking time, because football is everywhere. But that's okay, that's good. So transversal, it's because it cuts through the sidelines. So your sidelines are the lines that are going generally in the same direction, and that line of scrimmage, it goes through technically the line of scrimmage is a segment because there's a clear beginning and a clear end, but we know that there exists a line that will go through those. So that's a transversal. So what we're going to do now is looking at this diagram and having set these regions as interior and exterior and clearly having this transversal. There are angles on the left-hand side. I hope we all can see that. The angles 1, 3, 5, and 7, those are all on the left-hand side. And then angles 2, 4, 6, and 8 are on the right-hand side. And so we're going to call angles that are on different sides, we're going to call those alternating, because we're on alternate sides of the transversal. So we're going to come up with some new, not come up with, but learn about some new angle classifications dealing with this diagram. We know vertical angles, those are always going to be there. We know linear pair, those are always going to be there. But we're going to add 4 more. We're going to add 4 more. So I'm going to collect those colored pencils, so if you can just... Now over on the left of your notes, those 4 angles are listed for you and also defined for you. But we're going to put them in our own words, those definitions, and we're also going to find some examples of our own. They go in a certain order. They're listed on your notes as same side interior, alternate interior, corresponding, and then alternate exterior. We're not going to go in that order. Okay? There's a method to my madness, so just please trust me. But we're first going to talk about corresponding angles, so please find that definition on the left-hand side. Before we read that definition, there are 4 angles in this intersection and 4 angles in this intersection. There are certain positions. So angle 1 angle 1 is in the top left position. Does everyone agree with that? Top left. Angle 2 is in the top right position of that intersection. This is in the bottom left and bottom right. But you also have those same positions in this other intersection. You've got the top left and the top right and the bottom left and the bottom right. So if you look and read the definition of corresponding angles, it says that corresponding angles is a pair of non-adjacent angles that are in the same position but different intersection of 2 lines. One will be in between 2 lines and the other one will be outside. So one will be in the interior, one will be in the exterior of this diagram. But corresponding angles are same position, different intersection. That's what I'm going to refer to them as. So I gave you an example on your notes of 2 angles that are corresponding. And I said that angle 1 and angle 5 are corresponding in this diagram. They're both in the top left position. On that first blank of your notes, on that first blank, I want you to write 2 angles. Give me another example of 2 angles that are corresponding. I gave you 1 pair. Now please, from this diagram, please give me another pair of corresponding angles. Only on that first blank, because that other blank is going to come in handy in a sec. We're referring to the diagram we just got done coloring. Only in the first blank write two angles that are also corresponding. You're finding your own pair. Sayla, which ones you write?
Angle 4 and angle 6. I mean 8, that's
Angle 4 and angle 8, these two angles are both in the bottom right corner. So yes, those are corresponding. Give me another different one. Chris, yes sir.
Angle 2 and angle 6.
Angle 2 and angle 6 are corresponding angles in this diagram. And there's one more example that have not been listed yet. Yes ma'am.
angle 3.
Angle 3 and angle 7. So I gave you 1 and 5, and then Sayla gave us 2 and 6, Chris gave us 4 and 8. And then, so now we got 3 and 7. Thank you so much. So those are the 4 corresponding angles in this diagram. The next type of angles that we're going to talk about are alternate interior angles. So go ahead and find that on your notes. Alternate interior angles are a pair of non-adjacent angles that are between the two lines, so in the interior, hence alternate interior, and also on opposite sides of the transversal, hence alternate. So the name, the classification of these angles pretty much explains it to us. They're alternate on different sides of the transversal, and they're in the interior of it. So I gave you an example of angle 3 and angle 6, and that example was referring back to the diagram that we colored. Please give me the other example of alternate interior angles from that diagram that we colored.
Angle 5.
So there's only one other pair of alternate interior angles from that diagram, and it is angle 4 and angle 5. That's the other pair. Very similar to alternate interior is alternate exterior. So please find the definition of alternate exterior angles in your in your notes. It's the very last one near the end. It's a pair of non-adjacent angles that are on opposite sides of the transversal but lie on the outside, hence external. So I gave you an example of angle 1 and angle 8. I need you to write down in that first blank the other pair of alternate exterior angles. And Donnie's going to tell us the other example of alternate exterior angles. I gave you 1 and 8, and you need to tell me the other pair of alternate exterior. So